Hello everyone. In this lecture, we are discussing about introduction to plasma physics, and here this lecture will consist some topics. Our first topic will be the definition of plasma. Second topic will be the quasi-neutrality of plasma. Third topic is collective behavior of plasma, and the last topic is Saha's equation. And from that Saha's equation, we are going to prove that in normal temperature, the plasma state will not be possible. So, introduction to plasma physics. Uh, some of the people from you are already heard about plasma physics, at least heard about the name plasma. So, what is plasma? When someone going to ask you, then the first answer will be that plasma is a fourth state of matter. But plasma is not that much easy to understand, or it's interesting topic, but as well as it's also complex to understand. So the thing is that we have to, if we have to know deeper about the plasma, then just fourth state of matter is not a good answer, will not be a good answer. So before going to the definition of a clear definition of plasma, I just have some give you some ideas about that 99%. I'm going to give you some ideas that will amaze you that 99% of the universal thing are made of plasma state. So its example are the example of this state will be the stellar interior, gaseous nebula, interstellar hydrogen. And if you consider the everyday life, it's what I am going telling you the example. It's all are the outside of our Earth example. But if you consider the everyday life, or if you consider the examples of our daily life, then it will be seen very few, but the examples will be very few, but the examples are lightning bolt, aurora. You already people know about aurora things. So what's happening behind this aurora thing are actually the plasma state. Fluorescent tube, which are also known as neon tube. So I am going to give you the better understanding of this example later when we discuss about how the plasma physics, plasma state actually working. So let's go to the definition of plasma. So definition of plasma, as we say that fourth state of matter is not a very clear statement about plasma. If you have to say that what is plasma, then you have to give a clear definition. And what will be that? The clear statement of plasma will be that plasma is a quasi-neutral gas of charged particles, positive and negative charged particles, which exhibits collective behavior. So from that definition, uh, here we see that we have two topics that are unknown to us. One topic is collective behavior and the second is quasi-neutral gas. Okay, quasi-neutral collective behavior and quasi-neutral gas. These two things are unknown for us. That these are the new topic that we are discussing here. So before I'm going to briefly discuss about these two things. Mainly the thing is that in plasma. First of all, we have a clear vision of plasma. We sometimes say that say like that when we heated a solid, then it will become liquid. When we heat further heating of this liquid, it will become gas, and after if we continue heating the gas, in one point the gas will be ionized. Okay, This ionized state is called the plasma state. It is the clear answer of plasma state. Okay. So here from plasma's definition, we have two different topics that are unknown to us, and we are going to discuss about the topic collective behavior now. Okay. As you can already guess from the name, what is collective behavior? Okay, that it will work as collectively, but how it going to work in plasma physics, I am going to define you that thing. In ordinary air, the molecule, if we consider in ordinary air, not in the ionized gas or plasma state thing, in ordinary gas, the molecule are neutral as there is no charged particle. So the as the molecular neutral, then the electromagnetic force are not working here. The electromagnetic force are zero. Okay. There will be no gravity. The gravitational field will be there, but that will be very negligible. So, but it's for ordinary air, but it is very different when you discuss about the plasma thing. Okay. In plasma in plasma state, there I already told you that the gas will be ionized, so there must be a positive charge and a negative charge, which we'll call ion and positive ion and the electron. Okay. So it will move. Okay. The charged particles will move around along the plasma state, and it's generate the local concentration of positive and negative charge. And uh, while it is moving, then we all know that charged particles moves creates a electric field, and for that electric field, it's also create or rise the magnetic field. So the thing is that in uh, plasma state, there will be charged particles, and that's why electromagnetic force will be working here. So when you try to here, you can see in the screen that here is the plasma states are like that. Okay. Here you can see the positive ion, negative ion. The dot are here is the neutral gas atoms. uh, I said that there will be positive and negative ion, but some very few amount of neutral gas will also present there, which are actually negligible. So here the positive and negative charge will interact with each other. If you try to move one charged particles to another position, then all the charged particles will can feel the changes. Okay, so we from that thing we can say that positive and negative charge behave collectively because attractive and repulsive electric force are working here. We already know that when from Coulomb force we know that um, if there are two charged particles, then the charged particles are have some forces amongst each other. Okay, so that thing, that Coulomb force are working here. So we don't have any, we are not considering that state as normal ordinary air. So in plasma state, the all the particles are behave collectively. They one change can feel amongst the whole thing. So that is the collective behavior are meant to be in plasma state. Name quasi-neutral gas. Okay, plasma should behave like neutral. Don't confuse that. I am uh, in the previous topic I said that plasma is not neutral, but plasma is not neutral. It means that there are particles uh, in that plasma state. They have charged particles which are not neutral. Don't confuse between that thing. Okay. Here I said that plasma should behave like neutral as a whole. Okay, not as one particle. Whole plasma state should behave like neutral because the density of ions and density of electron will have to be same. Equal number of electrons, density of electrons and density of ions means the equal number of electrons and equal number of ions. Okay, so the number of electrons and number of ions have to be same. Have to so the net thing will be uh, so the net density of the plasma state will have to be neutral. As I say that the net density of the um electron and sorry plasma state will be equal, but so we can say that here neutral means all electromagnetic forces will have to be zero outside the plasma state. Inside the plasma state, the electromagnetic force are working, but outside the plasma region, the electromagnetic force will not be working. And here comes a topic called Debye shielding or Debye length, which we will discuss in our third lecture. Okay. We move to our next topic, Saha's equation. Why we need Saha's equation in plasma? As we say that earlier that plasma is all about the ionization gas. We uh, we ionization gas mean there have to be a positive charge particle and have to be a negative charge particle. So how we have to measure that how much ionization will possible in plasma state, that is measuring from that Saha's equation, and that's why Saha's equation are needed. Okay, mainly Saha's equation are for when are needed for when a temperature of stars, mainly astronomical background, Saha's equation are needed because when the stars temperature are accountable or have to measure, then Saha's equation are they needed. In that case, we have also discussed about the temperature, because without the temperature, without a certain temperature, for getting plasma state, we need 1 billion or 10 billion degree Celsius temperature. That's not a normal temperature state. We working like 300 degree Kelvin, but it's not that low. For getting plasma state, we need 10 billion, 1 billion or 10 billion times greater temperature from normal temperature. So that's why Saha's equation are accountable here. Okay. So what Saha's equation actually say? From that equation, we can say that Ni is divided by Nn is equal to 2.4 into 10 to the power 21 e to the power minus ui divided by kt. Okay. Here we have to know what that topic actually mean. In N1 is equal to the density of ions. Already we discussed about that. N is equal to density of neutral atoms. Here ions and neutral atoms density means the number of ions and the number of neutral atoms. Okay. Ui, the energy needed to remove electron from atoms. As we say that it is a ionized, it is in at ionized form. So the atoms should have to be separated. The electrons and atoms should have to be separated. Which for get a higher temperature, which energy are needed to separate the electron from atoms, that energy are deduced here by ui. Okay. K is, we all know that Boltzmann constant, and T is the temperature in degree Kelvin. Okay. So that's the Saha's equation, and I already told you about why Saha's equation are needed for ionization. Okay, so Saha's equation mainly needed how much ionization are possible for from plasma state. For that measurement, for getting a value, we need that equation. Okay, Ni and N actually said that fractional ionization. Okay, from that thing we can get a number which will tell that that much ionization. We can get a value which will told us that that much ionization will be possible from a plasma state. If we know the certain temperature and how much energy needed to remove electron, it's actually fixed, constant. All these things are constant, just the temperature here are varies. Okay. So now we prove that in normal temperature, the ionization will not be possible. As the ionization will not be possible, then the plasma state will also not be possible, because we know that in normal temperature, without ionization, plasma state are not going to stay. So, and we will prove it from Saha's equation. Okay. If we consider the normal air, because we are discussing here about the normal temperature, how normal temperature working in plasma state or working or not in plasma state, here we will see that for ordinary air at room temperature, let suppose that T is equal to the 30 degree Kelvin, as we say that it's a room temperature. UI is equal to 14.5 electron volt for nitrogen. It's fixed for atoms. It's actually varies from atom to atom. Okay. So K is equal to 1.38 into 10 to the power minus 23. It's, you all know that. So if we put all that thing in equation, Saha's equation, then we will get something, we will get the value something like that, which is very much low. Okay, which is, we can think that about tends to 0. So you can say that that thing is actually called the fractional ionization, which we get from that at room temperature it will 0. So from that thing we can say that if at room temperature the fractional ionization is 0, so at room temperature the plasma state will not be possible. Plasma will not stand there, okay, at room temperature. It's not going to happen. So that's the thing about the introductory thing about plasma. I already told you in the example that in everyday life we see a few example of plasma. We encounter few plasma states in our everyday life, but one is that we can see nowadays the thunderstorm. There we see how the plasma. Now we can see how thunder in the thunderstorm state the plasma actually work. Okay, we can see the lightning nowadays. So, where in there, how that is going to work, how the plasma state is uh, working there, I am going to discuss it in here. Okay. If now in rainy days we see a lot of cloud. In rainy days we see a lot of clouds in the sky. When the clouds are collides with each other, then a lot of temperature are arising there. Okay, lot of temperature are emerging there. So when lot of temperature are emerging there, then with that temperature the gas of this cloud will be separated or ionized. Okay, become ionized, and the heavy particle, which we know that the atoms, the ions will be the heavy particle and the electron are the lighter particle than atoms, sorry, ions. So that's why the heavy particle are going to the upper side of the cloud, and the lighter charged particles, which are the electron, will go to the lower side. Okay. Then in the earth, the same thing will happen when that that thing are happening in the cloud, then in the earth the same thing are happen. The heavier particle will move to the upper side of the earth, and the lighter particle will move to the lower side. So most of the time we see the lightning which are happening in between the, because we know that uh, electron will moving from towards to positive, and when electron are moving there will create a electric field, what we'll see, okay, as lightning. So most of the time lightning are happening in between the cloud, but when some other case are happening there, because when the one or some electron will come out of the cloud, then it will move towards the earth, and that's why the lightning will create and we see the lightning, okay, as they're creating an electric field, and that's why the lightning we see. And it's all about plasma physics, okay, plasma state.